Hi guys, welcome to our video tutorial. Today class we are discussing about the topic monitors. So monitor is one of the concept is used to we can make the solution to the critical classical problems of process synchronization. So in this monitoring concept we are using the high level abstraction that provide a convenient and efficient mechanism for process synchronization. We are using abstract data type. This data type internal variables only accessible by the code within a procedure. Only one process may be active within the monitor at the same time, but no powerful enough to model some synchronization schemes. This is a monitor example. In this example, we are creating the structure monitor with the name monitor name. So in between the modules, we are creating a shared variable declaration. So here we are declaring it to n processor shared variables procedure P1, procedure P2, procedure P3 and so on. Also we can declare the one initialization code. Based on the initialization code, we are invoke the monitoring concept. Here this is the schematic view of the monitoring. So in this view, this is the diagram. In this diagram, this is the shared data. So this shared data will be used by the some processor through this operation. So yeah, this monitoring concept is used in the semaphores and some other the dining table philosophy problems on the process synchronization and so on. This is the entry queue. Based on the entry queue, we can implement the shared data to the process. So we can share the data to the process with the help of the monitoring. So monitoring monitor each and every time. So which process use the shared data. So next one process is which one next process to view the use the shared data will be monitored by the monitor. So this is the operation implemented by the monitor, and so here also we can use initialization code. Each and every time the shared data will be assigned to any one process, the initialization code is used. We are using two conditional variables in the monitoring concept, x and y. There are two operations implemented to those variables. For example, x dot weight, x dot signal, y dot weight, y dot signal, and so on. A process that invokes the operation is suspended until x dot signal is invoked. So x dot signal is resumes one process is if any that invokes x dot weight. If no one x dot weight on the variable, then it has no effect on the variable. This is a monitoring concept with the conditional variables. This is the shared data. Here we can apply the two conditional variables x and y. So each with the implement the two operations signal and weight. This is the entry queue. It is the monitoring. The conditional variable choices. If the process be invoke x dot signal with the q in x dot weight state, what should happen next is if the queue is resumed, then p must wait. The options included for the conditional variable choices is signal and wait and signal and continue. So signal and wait means a p wait until q leaves the monitor or wait for another condition. The signal and continue is q waits until the p leaves the monitor or wait for the another condition. So both have props and continuously live implementer can decide. So monitor is implemented concurrently. So the Pascal compromise. Implemented in the other languages like Mesa, C, Java and so on. The solution to the dynamic philosopher is with the help of the monitor. Here we have to create the data structure dynamic philosopher with the monitor. Here we can declare the enumeration variable constants, thinking, hungry and heating. So based on these three constants, we can implement the solution for the dynamic philosopher problem, the state of an array. Because there are 5 processors, so processor can use the shared element in the dynamic philosopher. So we are using a conditional variable self with the, and then we can define a function between the structure is pick up and put down. So with the help of these two functions, we can implement the solution for the dynamic philosopher problem. In this pickup, we are first of all we can assign the constant angry constant to the state of I, and then we can implement the test function after implementing the test function, and then we can check the condition. If the state of y is not equal to eating, then we can call the self dot wait function. Same as in the put down function. So we are pass the one argument to the put down integer argument to the put down function based on the argument. So first of all, we can assign the thinking enumeration constant to the variable state, and then we can test left and right neighbors with the help of the two functions. Test I plus 4 modulus 5 and test I plus 1 modulus 5. Based on this, it will be repeated until the condition is true. This is the solution of dynamic philosopher. This is the test function with the help of the integer constant. If first of all we can check the condition, state of I plus 4 modulus 5 equal to eating. Also we can check another two condition, state of I equal to angry. Also we can check the another one condition, state of I plus 1 modulus 5 not equal to eating. If the three conditions are true, then only we can implement the statement state of I equal to eating. Also we can immediately we can implement another one statement self of I dot signal. This is the simplest code for the solution to the dining philosopher problem. So in this solution, so each philosopher invokes the operations pick up and put down. Based on these operations, we can implement create the solution easily. Next, implement monitor implementation using the semaphores. We can use the monitor concept in the semaphores concept. Here using the three variables, semaphores mutex, semaphores next, and one integer variable next count. So both the mutex initialized with the 1 and next is initialized with 0. Next is the procedure f will be replaced by simply weight and signal function. Once weight of mutex is created, the next the critical section statement will be placed here. After executing that, next first of all you can check the next count greater than 0. If the condition is true, we can implement the signal of next. Suppose if the condition is false, we can implement the signal of mutex. Same as the monitoring implementation for the conditional variables. The same as the semaphores, here also we can using the conditional variables for x and y. So we can apply the monitoring concept for x and y conditional variables. The resuming process within a monitor is we can using the FCFS frequently in our academic. So conditional weight construct of the form x dot weight. The monitor allocated single resource is we can using the monitor resource allocator. With the help of allocator, we can using the two functions. One is acquire, another one is release. With the help of two functions, we can make the solution to the single resource allocation with the help of monitor. That's all. Thank you.